Okay, so we'll start then, and thank you everyone for joining, and I'm going to give you a brief update involving what we've been up to for the last year, and this is in behalf of both myself and Clara and the whole working group. So go to the next slide. So just to give you a taste of what we've been up to, first, it's just become during the second year, it's been a once per month telecon we've had, and much of that focused over the first half of this period on the finalization and development of Clara's nature climate change manuscript, and that was actually a longer process, but it was published earlier this year, and it drew on both the research experience of people internal to the working group, but also on the workshop we held last summer. So we'll come to that in a second. And we also had a large ensemble session at AGU where a couple of us were conveners. So we can go on to the next slide. So one of the more important things to report first is that we've continued the extension of the multi-model large ensemble archive, and that's been pioneered by Flavio Lehner, who has a joint affiliation, if I understand correctly at this point, between NCAR and ETH in Zürich, Switzerland. And this is an archive that has the main models that have been archived have been typically CMIP5 class models, and they're documented here, and these have been made available to the international community, and these have been the hub of the activities that we've been promoting and developing. So if we can go to the next slide. And additionally, with the documentation and information that's communicated by the working group and also through the efforts of Flavio Lehner, there are other large ensemble resources that exist as part of CMIP6 that are available and served through ESGF, and so we are pointing people to that resource, although they will not be hosted as part of the MMLEA that I mentioned in the previous slide. And so there, you can see here there are a number of different things that are now available. So we can go to the next slide. So very quickly, an overview of the workshop from last July. This is a photo of the participants. We can go to the next slide. It was hosted in Boulder at the Mesa Lab, and this is just a list of the people that were involved with organizing. In addition to Clara and myself, there were a number of more earlier career people. And if we can go to the next slide. The important point to communicate here is that the workshop was viewed and experienced as a way of both seeing what the state of the art was for research with large ensemble methods, and we had some really wonderful talks with a wide range of topics, ranging from public health to more familiar climate dynamics questions to biogeochemistry, and just a really broad range. It was very exciting, and but of course there was an important component of it which involved the breakout groups and sort of polling the people that are active in this community to get information moving forward. So just to quickly run through some of the points that were raised during the workshop. In the near term, there was this issue of continued. The question was raised as to whether we should, at the workshop, we should prescribe as a synthesis effort, prescribe protocols, and the general sense was yes and no. But really, it needs time. There needs to be more exploratory work done with the existing archive. So that's item number one. Number two, there were some recommendations that were made that were very clear about moving towards future protocols in terms of the importance of mixing micro and macro perturbations for initialization, and the value of extending single forcing or all but one forcing ensemble directions, the value of perturbed parameter ensemble experiments, and also to further collaborations and nurturing projects that are a little bit outside of the community of where the large ensemble research began, more moving out from the physical climate community towards people that are looking more specifically at impacts and things like that. So item number 3 here is that there were other recommendations. There was a lot of interest in machine learning-based methods for reconstructing climate variability. And the final point here is that there was a lot of enthusiasm for, this kind of relates directly to point number 1, for perhaps having a workshop in a couple of years after the one last year, which would mean next year, as a forum for assessing community progress, but also, as a possibility for articulating the protocols that the community thought would benefit from a little bit more work with the existing. The archive had only really come online recently at the time of the workshop. So the community seemed to want some time, but was interested in this issue of protocols. Okay, we can go to the next slide. Okay, so another, as I mentioned before, Clara was lead author on this paper that was a group effort by the working group, and it was a perspective piece for nature of climate change. And you can see from the title, it was just a broad title. And we can go to the next slide. So just to step you quickly through the main figures that were in this paper, the first figure shown here is a look at the multi-decadal trends in temperature over North America. So considering the period 1951 to 2010, and the lines in the figure, the horizontal axis is temperature, and the vertical axis is relative density. So these are PDFs. The lines represent large ensembles, and for these 60-year trends, and the distributions, and the vertical line represents an observational record for this for the trend over this time for this region. And the important points here are that the gray shaded area represents CMIP5. So the most important points here are that the spread for the CMIP5, the gray, is only slightly wider, broader than for individual large ensembles, and also that the span taken together of the multiple of the large ensemble collection from the MMLEA is spanning a wider range than the CMIP5, and that the implication there could be that CMIP may undersample some of the variability in the system. And so we can come back if there are any questions. But just to go on to the next figure for the moment, we can go to the next slide. Okay, so here the idea was looking at the upper Colorado Basin and turning attention to sort of decision making and risk assessment questions. And so considering a region in the models corresponding to the upper Colorado Basin, the upper panel, panel A, so the time axis is 1950 to 2100, shows 10-year running means of precipitation anomalies relative to the part of the earlier period, 1971 to 2000, I believe. And it shows a diversity of outcomes for future projections under this relatively strong emissions RCP 8.5. And the panel, so you can see the individual lines are ensemble means, and they're color coded, and the spread of the individual ensemble models are given as broader, just the lighter colors corresponding to the lines. The lower figure is showing the changes in the standard deviation relative to the period 1971 to 2000, and you can see that there's a tendency towards increased decadal variability in the system. So again, in the upper panel, these are working on 10-year running means. So this corresponds to decadal variability, and the information from the lower panel is that there is an increased risk of drought periods and fluvial periods that is projected by the models. And the changes there are therefore of importance to risk assessment and decision making. Okay, we can go to the next figure. Okay, so this is showing for a more specific region for the upper 5 panels here, which are similar with these vertical lines, and then the lower panel, which is, so the upper 5 panels represent CESM1, members of the CESM1 large ensemble, and the lower is more together a collection of different models that were included in the analysis. So first, for the upper 5 panels, there was a definition over the period 1950 to 1999 of the 99.9 percentile of precipitation in July. And then, so that with the time axis moving from left to right for the upper 5 panels for independent ensemble members, this shows the effectively the daily heat extreme the occurrences of daily heat extremes for 5 of the CESM1 members. And you can see that not only are there differences in the number of events, which are given on the left-hand side of each of those 5 panels at the top, but you can also see that there's a difference in when the events hit. So if you contrast the second box with the fifth box, you can see that the second box, which has the most events, has them more concentrated towards the end, after 2060, whereas in box 5, which has fewer events, 386 events, you can see that they're more distributed. They're not as concentrated in one particular era, and this is reflecting the importance of it reflects differences in the natural variability in the system, in the different ensemble members, and how that can impact extreme events. And then this panel at the bottom is showing, with a similar definition for different large ensemble models, the time evolution for the same grid point corresponding to a location corresponding to Dallas, Texas. This shows the frequency of the probabilities of exceeding the 99%, the historical 99.9 percentile for different components of the multi-model large ensemble archive. And so you can see the differences. There are differences between the models. And again, we can come back to this if there are any questions. I guess let's go on to the next figure at this point, which is the next jump ahead to the great. So this is showing, this is bringing in the observational large ensemble, which is an application of a method that was developed by Aaron McKinnon and Clara. And it's, for those of you that are not familiar with this, the observational large ensemble is best understood as a statistical approach to creating ensembles for variables that are informed by observations to overcome some shortcomings of the models. And the upper panel is really, I guess, so it's creating a statistical ensemble based on one member of CESM, and then testing the extent to which the spread of a statistical ensemble created from that is consistent among the ensemble method, the different members. And the point being emphasized here is that this is a representation of the error of the method, and it's in the exotropics over land, it's relatively small. I guess you can see there are some larger signals over the tropics, but over the exotropics it's relatively small. And then the lower panel is a question of, once the skill of the observational large ensemble has been evaluated in the upper panel, then the realization of the internal variability can be assessed with the observational large ensemble relative to the observational large ensemble versus the large ensemble. And so the lower panel shows the fractional error of temperature trends. So this gets back to the first figure we had seen with the temperature trends over North America, to that concept. This shows the error of the model, fractional error, for the temperature trends over large scales. And you can see, again, there's this green panel inset here that is showing the difference in the width of the distribution for temperature trends corresponding to Dallas. And so this is highlighted as an important way to bring some kind of information from observations about natural variability into the study of projections. So let's go to the next panel. So here is just a quick overview of the plans for the future. One is to extend the archive, continue extending it. CLIVAR has reported that Adam Phillips, who has developed the climate variability diagnostics package for large ensembles, is going to release this in late summer, and that this will be of broad interest to the community, and there's a potential for a webinar. Third item is the development of further large ensemble working group publications. Fourth is the formulation of white papers on best practices and strategic decision considerations. And depending upon COVID and other issues, there's the question of convening sessions at meetings coming up. And then there's the issue of more organized activities, whether a hackathon and or another large ensemble workshop. So these are things we're actively discussing. If we can go to the next slide, please. So this is, we can run through this very quickly. This is Adam Phillips, what he has developed with CLIVAR for an interface for doing large ensemble diagnostics as an extension of the climate variability diagnostics package. And if we could go to the next figure. So this is showing for the case of the AMO. The left panel is from an observationally derived pattern, and the right is a pattern derived from CESM1, doing, if I understand correctly, doing separate for each ensemble member, and then taking an ensemble, averaging across the different ensemble members to get this pattern. And then if we can go forward, and this is just a list of the models again. If we can go forward one more. So then we get to the point where we have, so this is a repeat of the previous figure, except now we have this additional panel, which shows the rank of the observations within the ensemble, and the idea being that the white areas are where the observations fall within, I guess here it's between 20% to 80% of the ensemble spread, and that thereby the model is doing a good job. So this is something that can be applied for the models within the archive, in addition, obviously, to CESM1. So I think CLIVAR would be better able to field questions on this, but this is very promising and very exciting. So we can go to the next. And then just to wind down, one thing with this with the CESM2 large ensemble is through a lot of a lot of working through initial condition questions and other things that have been informed through working group and workshop activities and other information, community informed avenues of communication. We are jointly in a partnership doing the CESM2 Large Ensemble Project, and so we're running it on a Cray here in supercomputer here in Korea. And so far 40 out of the 100 planned ensemble members have been finished, and we are still brainstorming about the best way to do this, but in terms of a hackathon next year, perhaps building on what was done with CMIP 5 last CMIP 6 last year, was organized I think by Ryan Abernathy and some other people, Matt Wong and John Dunn. It would be perhaps an opportunity with something Python based to build on that. So anyway, so this kind of is a little bit of an aside, but I think it fits into some of the activities that will be going on soon. With this will be included in the working group, in some of our research together. Okay, so can we go to the next slide? And this is just returning to the same figure you'd seen before, just as a closing figure with the steps ahead. So I believe that's the last figure, just to leave that up. Yeah, that's.
Maybe I could just add one thing. Hi, Keith. This is Clara. Thanks
Hi.
so much for such a nice overview. Maybe one thing I didn't see in what you reported on is that Jenny, you can correct me if I'm wrong, but there will be an issue of the CLIVAR variations publication devoted to large ensemble papers, and I think that's going to be sort of late summer. And we have 5 excellent groups of early career scientists who are going to at the forefront of new things that can be done with large ensembles. And I'm really excited that they all accepted to be authors. And I think it's going to be a really excellent collection and useful collection of papers.
I think this variations, we are working with the authors now to get the drafts in. So expect for the publication to be around mid-July, and then we'll have a webinar hopefully by around early August, so that you can have an opportunity to ask the authors some questions on their papers or on their articles.
And yeah, Clara, thanks for pointing that out. And these are in large part people who early career people who largely participated in the workshop last year that generated enthusiasm with these sort of new directions and new ideas. So it's
exactly.
So with that, I think do we have any questions from the audience for Clara and Keith?
Hi, Keith and Clara. Thanks a lot for this overview. So one question I have concerns the observational large ensemble. So I haven't actually read the paper on the observational large ensemble, but it seems to me that that's an area that also needs to be explored more, because we have all this large ensemble, and when you, in spite of the number of members in each of them, you still have a large spread among them. So I think some guidance from using different approaches to try to constrain the results through observation and comparison seems to be very important. And so you mentioned before the use of machine learning techniques for reconstructing climate variability. Is that also intended to provide an observational constraints?
Clara, you've had more direct involvement with this. Maybe would you like to comment on that?
So I, from the beginning, I've always felt like this we need, as you said, Antonietta, ways to evaluate the internal variability in models. And our records, observational records, just aren't long enough to sample multi-decadal variability robustly. So then, we need to develop these statistical emulators, basically. And so I think a lot of people are doing that. I'm trying to keep my keep my eyes and ears open. There's a group at ETH, actually, and but it is something that I'm trying to bring to the forefront for the working group in this coming year. These machine learning or ways of doing statistical emulation. And the beauty of having model large ensembles is that you can test your method. So you can take each member, do the emulator, and see how close, how well do you emulate the statistics of multi-decadal variability, and then you can test that against all the other members of the ensemble, and then you can go forward with your method with the observations. I think we should try to I'm not sure how to do it, but I think we need to make a more concerted, coordinated effort somehow with these developing these approaches. I don't know if it's maybe joint with the machine. I thought there was a new panel, Mike, or something. And maybe it goes maybe it's, just a natural kind of then synergy in the last year of this working group and the first year of this other working group, that maybe we can really bring the people with these tools to really make some progress. Yeah. One thing, or I just add. So a student of Sonia Seneviratne in ETH Zürich, Leah Boisch, if I pronounce the name correctly, she has a beautiful statistical emulator, and it works very well for, grid box level variability. But, that's not enough. I mean, it's excellent, but we have to go to the patterns, the spatial patterns of variability. And so it's not enough to just treat each location independently, but we really want to know, are the patterns of variability properly simulated?
Yeah, and I think also using different approaches to do that would be very, very important, because
I agree. So if any of you have sort of ideas for, I don't know, how we get this sort of a focused group to really just come together and decide that we need a group that brings different approaches, maybe to the same data. And then we can really start to make progress.
Yeah, something to think about.
Yeah.
So this is Mike to hop in on that. I think finding time between the two working groups in the next, say, 6 months to have a bit of dialogue could be useful. I also wonder for your ideas for either a second workshop or the hackathon, whether those might be good venues to have this topic addressed actively there as well. On the hackathon, I do have a follow-up question. So given this upcoming release of the CESM, or this second large ensembles that's being done, Keith, you mentioned with the South Koreans, with that release, and then with the release of the diagnostics package, Claire, that you and your group are working on, it sets the stage for this potential future hackathon as we have an expansion in the archive of the data sets that are available, especially these very high resolution ones. And so On the timing of that, are there plans already in progress for organizing such a hackathon, or is that something that's going to be proposed downstream?
Nope.
Okay.
Clara,
Well, I would say that in the final session of the workshop last year, I remember standing up and saying, you know, should we reconvene in a year or two? And what do you think about the idea of a hackathon? And I think people really like that idea. So I think there is enthusiasm. Keith and I haven't at all talked about anything concrete in terms of plans, but I agree that now with the CESM2 100-member ensemble coming on board, and this real need to not only continue analysis, of course, of the model large ensembles, but the critical need for these observationally based large ensembles. I think it's a great idea, Mike, that we really, at least one of the foci maybe of such a hackathon could be, you know, methods for observationally based large ensembles. I think it would be excellent. I don't know if we need to wait till a hackathon can be done in person, or if it does work to do it virtually. I think Isla Simpson had participated virtually in some hackathons, so I'm sure there's some, you know, pros and cons. But if it's virtual, then if it's in person, then I guess we better wait till next summer.
I feel like either everyone being in person or everyone being virtual is optimal. I feel like having half and half didn't work too well, I don't think.
Yeah. Okay.
I'm Shoujo. Can you hear me?
Yes.
Yeah, I strongly support the virtual hackathon as an international member, because if that is an in-person hackathon, it is very difficult to us to attend. For example, we can attend science meeting to present our results, but we can't use our funding to attend the hackathon. But if that is online, then international researchers can attend. So I'd like to suggest that is very good way to expand the user group of the large ensembles to use promote the internet online hackathon.
Okay, great. And I remember now that the Karen McKinnon's the impetus for, well, she developed the observational large ensemble, the first rendition of it, at a hackathon. It was the Rossby Palooza hackathon at University of Chicago, and it was whatever summer it was. And she came back from that and she said, Clara, I have an observational large ensemble. So yeah, okay. I think that would be excellent, an online hackathon.
Yeah, of course, there is the time zone issue, which, depending how broad the international participation is, can limit like the effective time. But I don't know, maybe one can do different sessions for different time zones.
I guess we're still human beings.
Yeah, time zone is a problem. Yes, but still, I think that provides a better chance for international people to attend that hackathon.
Yeah. Great.
So Keith and Clara, I have another question, and it has to do with the publication, the focus of your publication on best practices. So for this audience of panel members, can you speak to what you envision there? I know the working group may not have gotten too far down this road. You guys have been quite busy with your other paper and the putting together the summary of the workshop report and all of that here recently. But what do you envision to be some key targets for best practices for the community?
Clara, have you given this?
Yeah, I guess so. It kind of dovetails with this diagnostics package that we're developing for large ensembles, and I was encouraged when I presented it to the I guess to the working group maybe a couple of telecons ago, and several of the working group members who are also faculty members said it would be this could be such a great teaching tool, but we would need a kind of user's guide to how to interpret the results of the diagnostics package. So I took that to heart, and I wrote a draft of, just okay, when you compare the NAO, across different large ensembles, what is the information? What information do you need to be able to compare models, to be able to assess the internal variability of the NAO, the forced response of the NAO, the credibility of models against the observational record, issues like that. And also then how the NAO might change in the future and the model dependence of that. So I feel like I already have kind of a bare bones sort of outline, or more than that, I've written a lot. I think that could be taken then just as a starting point, and maybe then I was going to share it with everyone in the working group when we've actually, released the package in a month or two. But I wanted to get feedback, especially from the educators, to see, to make it as useful of a how-to-use guide, and pitfalls. This package and blindly using large ensembles, you can come up with garbage, of course, if you don't really understand, if your record is too short, you really can't say much about, model performance, that kind of thing. So I think maybe I could see a group of us in the working group, maybe a subgroup, or the whole working group, who could then take maybe as a starting point what I wrote, and then that could be turned into a best practices. Some of the figures that Keith showed from our perspective paper, it started actually, that whole paper, as a best practices. I would say, how do you make informed use of large ensembles? And so I think some of that material is already in that perspective. So I think we should. I think we can. I think it's a very doable project in this coming year, and I think maybe we're already on track with this documentation for the diagnostics package.
And as a complement to that, I think that's a great idea. And as a complement to that, with the new, there's some very technical issues about whether things are Seymorized or not Seymorized, but that's not really that important. But with the Python code that we're developing, that we're already developing to look at some of the new large ensemble output, in addition to putting that, just put to GitHubbing it or whatever, we could also make something useful in terms of a tutorial with some of the Python, for code that could be applied specifically to large ensemble questions. Perhaps going through, whatever it turns out to be in the presentation paper, or even, going back to some of the things that are in Clara's paper, and thinking about, we could take the large ensemble efforts where we've actually, the things that have been working group activities, and maybe bring some of that into something more like a tutorial that could be in the PDF file or something online that could be maintained.
I think that would be great. Maybe Jupyter notebooks, right?
Yeah, that would be probably very, very, very widely.
I think that would be extremely, extremely useful. Yep. So not just sort of words about how to use large ensembles, but actual coding.
Yeah, that should be possible.
Yeah, Great.
So Mike, does that
Yep, go ahead, Keith.
I was just going to ask Mike if that does that. So in terms of best practices, those are very more specific kind of analysis tools. So, but is that...
Yeah, no, I think the guidance, I think the idea behind best practices is to identify, the kind of key areas where guidance would be helpful for the community. And so I think that sounds right on track. Yeah.
Okay. Great.
Any final remarks for Claire and Keith before we close this telecon? Right. So I don't see any. Unless, do I hear someone? No, okay. So I guess we'll end this meeting today. So thank you, Claire and Keith, and all of the other Large Ensemble Working Group members for showing up today. I know that might not be the right time zone for you guys, but we appreciate you showing up, and everyone else who's on the line today. We will reconvene next week for our final working group telecon at the original time, so 1 p.m. Eastern time, and that one will be our AirC working group with Piode and Larry O'Neill. So I will, if I don't talk to you this week, I will see you next week. Thank you all.